And so for this program, we're going to get a little bit deeper into the branches and conditionals. And essentially what we need to do in this program is create a switch statement. Because every letter has only one pair, it means that if we have an A, we need to store a T. If we have a T, we need to store an A. If we have a C, we need to store a G. If we have a G, we need to store a C. As you may have guessed, however, we don't actually have a switch statement that we can use, and we have to actually write this out in long form by doing multiple comparisons linearly. What we can do is obviously make it short-circuiting, which means that the first time it gets a match, then it just ends. But what does that actually look like? So the first thing that you see in this template is that we have the input string of one side of the base pairs, and we need to match it up to the other side. So we have our right, this from the null right that we've used in the last couple of exercises. We have our global directive with the start label, and then we have the start label. So the first thing that we really should do is actually load the address of the string so that we can access it. So we do that with the load register, and we'll put that in register 0. And then before we get too far, let's put a note up here about what our registers actually are doing. And so we need to read it bit by bit and then do the pair. For right now, let's just pretend it was one letter. This is how I like starting this, because if it's a loop, it's going to do the same thing over and again. So let's just think about one letter. For the first letter, we want to read it, and we can do that with load register byte. And we'll put that into register 1 because it's available. And we want to read what's at the address of register 0. So up here, we'll just make a quick little note. Register 1 is our temporary red byte. After that, what we want to do is we want to compare this to 0 first, because the first comparison we always want to make is to see if it's the end of the input. And so we'll do that first. Compare what we just read to 0. And if it is, we need to get out of it. So we're going to branch if it's equal to 0. And we will just leave this empty for now because we don't know yet what it's actually going to go to. So the first thing that we have is let's start with A. So let's see if we have an A here. We're going to compare our 1 with A. And again, you can use a single char by putting the number sign and then the character in single quotes. And if we have this, if this is A, what we're going to do is we're going to store the matched character in another register. Let's try that. So we'll come back up here to the registers. And R2 will say, so because we have to have the letter that we're going to write in memory before we put it in memory in a register, we'll just put it right here in R2. So if we have an A, what we want to do is put a T, because A and T are a pair. And then we're going to branch if it's equal as well. And let's, for now, if we're at the end of the string, we'll go to an exit label. And so we'll put that down here because we know it's coming. And if we found the letter and we want to write it to memory, let's just go to a write label. And we can change this if something changes, but I think for now. And you may notice what I did is I used 2 equal suffixes in a row. So the CPSR the current program status register doesn't update itself on every operation. It only updates itself on operations when you ask it to update itself. And so what happens is in line 25, you're comparing the red byte to the letter A. And if it's equal, then we're going to do both of these two operations, the move if it's equal and the branch if it's equal. If it's not equal, it'll just skip these two lines. So let's do the next one. Let's try comparing it to, well, if we do the A, let's do the T. Makes sense. And then the same thing is if this is equal, we're going to move A into register 2 and then jump out of the loop. So move equal, if equal, to register 2, and we're going to put A here. And then we're going to branch to our write label, or what we're calling our write label right now. The next match is, let's go to the other pair, and so we have C and G, and let's see if the red byte is compared to C. So we'll compare the red byte to C. And if it's equal, we're going to move to the letter that we write in register 2 is going to be G, because C and G go together. And now if we've made it this far, and then we need a branch. If we made it this far, we only have one other choice. If it's not an A, a T, a C, or if it's not one of those, it's got to be a G. And so for this last one, we don't actually have to do a comparison. We can just say, if we got to this point, we can move into register 2, the last letter, which is C. And so that makes sense, right? We compare it to the A. If it's not A, we compare it to the D or the T. If it's not T, we compare it to the C. And if it's none of those, then it must be a G. So we'll just store the C. This is one of those cases where you'll notice that I didn't reserve any space for the output string. Because everything is a one-to-one relationship, what we're going to do is we're just going to write the output to the same memory address that the input string is taking up. And that way we don't have any other memory that we need. We just use the memory that's already allocated for the input string. And so what we're going to do is we're going to store byte. We're going to store what's in register 2 because that's what we're the place where the letter is going to be stored. And we're just going to put it in register 0, and we're going to increment it. So if you think about this, so if we have a G, if our first one is a G, it's going to compare it to A. It's not A. Or it's just going to compare it to T. It's not T. It's going to compare it to C, and it's not C, so it must be a G. It's going to move C into register 2, and then it's going to take that C and it's going to overwrite the G. And then what we need to do is we need to loop it. So I use the loop keyword a lot. When you have multiple loops, you can't just name it loop, but for now it's fine. So let's look at the next character. So if we've incremented 1 in the memory address, and so we're going to read the second letter in the string. And it's a T. So we compare it to A, it's not A. We compare it to T in line 28. So in line 29, it's going to put A in register 2. And then in line 30, it's going to jump down to write. Write is going to overwrite the T with an A, increment the address, and then we're going to branch back up to the loop label. And that's pretty much the program. Everything after this is just writing and such. So let's do our null write, because we have a null terminated string, and we'll give it the instr label, and that loads it. As you've probably found out by now, I really enjoy having a line ending that that makes it look a little bit nicer when it gets printed out to the standard out. And so what we can do is we can actually store a new line like we did before, but we can also store it with an additional null byte and have it just write the output or write the new line by calling our null write again. And so let's do this. We're going to do our LDR again. Let's put a note here. We're going to say load and print line ending. So because null write is a macro, and we're not sure necessarily without getting to opening it back up and worrying about it, we're going to assume that it trashed all the registers. And so we have to build up again. So in register 0, let's put the address to our in string again. What we're going to do is we're going to move a value into R1, and we're going to move in the value 000A. And when you look at this, you would think that it'd be, so 0A is the hex for the new line character, and 00 is our null byte. And when you first look at it, you may be a little confused. You may think, shouldn't it be 0A00? And the answer is no. You have to think about how these sit in memory. And when we build this, the first character is going to be at the very end, and the second character is going to be to the left of it. And so when it's read out of memory, what will happen is, because of the endianness of the memory, is it'll read the 0A first, and then it'll read the 00. And so we have the new line and then the 00. We don't actually need the 00, because if we move the value 0A into register 1, it will zero out everything else because the value is 0A. But again, this is one of those things that I do for clarity and not necessarily for actual function. When this gets compiled, it'll drop that 00 and it'll actually drop all 3 zeros and just load the value A into register 1. And so we need to store this now. And we can do two things. We can either store all 4 bytes, or we can store just the 2 bytes. Since we haven't just stored 2 bytes before, let's do that. And so in the same way that we do the store byte, we can store H, which is half word, which is 2 bytes. And we're going to store the value that's in R1 to the address in R0. The reason we can't store 1 byte is because it'd just be the line ending. And then when we call null write here in a second, it will print out the whole string again, except for missing the first character. It'll be on a new line. And so let's call our null write again. And the same in string. And then after that, all we need to do is exit the program. So we'll set up our syscall, our supervisor call, by moving into R7 number 1, because 1 is the exit. And then the only parameter that we need at R0 is the error number, and we'll put 0 for no error. and then call the supervisor by svc0. And that should be everything that we need. So let's try this. The other thing that I want to do really quick is let's make a make file, because this will make our life a little bit easier. And we can use this make file in future projects as well. We may have to edit it a little bit depending on how many files that we need to process. But this is like the OG grunt or gulp or whatever project running software that you use in your language that you usually program in. So the first thing that we need to actually define is the files that we need to create the final result. And so for this one, we only need one file. We just need the main.o because the write.s is included into it. And so we don't need that file. We don't need a write.o, but we do need the main.o. So we can go, we'll call this a variable called obj, objs for objects, and we just need main.o. And so the way that a makefile works is that you define the files that it wants, and then you give it a recipe of how to get it. And so for every .o file that we need a .s file. And so we'll say for every .o file, we're going to need the .s. And what this is just saying is that it's going to be the same name. If we need the main.o file, then it's going to be main.s. And you need to put a tab, and it's super important that it's a tab and not spaces. If it's spaces, it'll fail. And we put the command. And so as for our assembler. And then the special variable money sign left caret is the source file. And then we're going to output money sign at. And that's our output file. And so it's the same thing. If you substitute it in, I do it the other way around. I usually put the output first, but it doesn't matter. We would assemble main.s output main.o. And then the other thing that we need out of this make file is the main executable. And because it's going to be just main, we're going to put main. And then the files that we need to build main are the files that we listed at the top. So we'll put that, which just fills in that string from the top. And then the command that we use for this is ld, our linker. Our output is going to be main. And then again with the list of object files that we need to put in. If we close this and type make, you can see that it runs those commands for us. If we just run the file now, this may take a second. I'll just verify the first beginning. CATAG, CTAG, CTAG. Yeah. If you want to go through the whole thing and verify it, then it's there. But if you don't want to take my word, you can go through it yourself and make sure that all the letters are correct. So that wraps up our branching conditionals overview. The next thing that we're going to do is start working with numbers and actually do some math